Hey everyone, Blake here. And I've noticed an issue that I've had with machine learning, and sometimes I'll have a problem that doesn't train right. And often it's because I have screwed something up. But there have also been a couple of times where the behavior in training didn't match what actually happened when I brought it back into Unity and ran the program. And so, for example, the floaters live stream that I did a few weeks ago worked fine then, but I tried to build it out more, and I was getting this really odd behavior where the agent would act in a way that didn't really make sense. Like, it would do the right behavior in just the wrong spot, and it was proportionally the wrong spot. And so I thought there was an issue with the execution, the training execution, and then the in-game execution of the ML stuff. And I couldn't figure it out, and I couldn't figure it out. So what I did is I went back, and I did find that I had an issue, there must have been a bug or something in that version, because I don't have that issue anymore, when I did a pull. So something somewhere got fixed. But I thought it would be very, very useful to have the hello world of machine learning. And so this really serves a couple of purposes. One, it allows somebody who is new to this machine learning agents, I want them to look at a well-engineered but super simple example. And so that's what I think that I have. And then the other one is it provides a way to test the end-to-end configuration of your ML setup very, very quickly. Because this is such a simple example, it hardly takes any time to train. And in fact, for the purposes of education, I've kept it so simple. There's no prefabs or anything like that. So it's literally 2 script files, a bytes file, and a scene, and I think that's it. The entire goal is, and I'm going to go ahead and close this game tab for now. The entire goal, you are the white marker, and you can go up and down, and you are trying to get to the red target. That's it. Right? You have one axis of movement. You can go up, you can go down. That's all you can do, and you're just trying to get that target. At first, I had a floor and was working gravity and stuff, and then I realized, no, I can make this simpler and simpler and simpler. This is the minimum viable product for this kind of problem. So this is as simple a problem as I could come up with using the continuous space of the Unity machine learning tool set. The other thing that I did was I went back and I looked at some of the examples, and I tried to understand when I was first starting out what were some of the issues that I had with some of the examples. And I had a couple of issues. One was that there were some files whose use weren't necessarily clear to me. So the 3D ball example that had a decision, and the decision actually had a bug in its logic that was very clear to me, and I didn't understand that the decision wasn't being used in most of the game modes, right? So this, I pared it down and I focused really on the simplest scenario that I could get. So here we are, the simplest scenario. And I'm going to walk you through it, and I'm going to walk through building it. It's like 50 lines of code. It's super low-key, but it's also designed to be well-engineered to show a really good example of what a starting environment looks like, and then people can build out from there. So I tried to use all the best practices that I could on this one tiny little problem. So we'll go through this real quick. The main scene. This is the scene that you are looking at now. The target material, that is just this material. The hyperparameters, we'll get into that later, but you just copy and paste this into the hyperparameters portion of your PPO algorithm that they provided. We have now gone through literally half the files in this project. The generic academy, so this is just using the default academy. We didn't add anything to it. So this is a whopping, 12 lines of code or something, none of which actually do much. It is just instantiating, the simple default academy. So yeah, 20 lines of code, but really, it has a bunch of white space in it and stuff. So this doesn't do a whole lot, right? And that's fine. And we can actually use that for a number of projects. So that's 4 out of 6 files. This is the bytes file that is an output, so if you just want to test and make sure that your TensorFlow Sharp configuration works, you can load this in and use the internal brain and use this bytes file, and that will test that. That's 5 out of 6 files. And so the last file we have here is our simplest agent. Okay, just loaded on the wrong tab. Which again is 54 lines, including white space and comments. So here we go. What do we need? Well, this is an agent, right? We have a marker, this guy, the target, that guy. They start somewhere above or below each other, so the minimum height is -1 meter, maximum height is 1 meter, so either of those can start up in any of that range. Again, I noticed that in a lot of the demos that they provided, a lot of the values were hard-coded in the code, and so I wanted to expose these as public so that you can play with them in the editor. The marker speed, this is how quickly the marker moves up and down. Distance to earn reward, how close does the marker have to, how close does the marker have to be to the target in order to earn a reward? And then on marker points, this is the reward when you're close enough that you earn some reward. This is how much of a reward you earn. So by exposing these parameters easily in the editor, you can actually go over here to the simplest game and you can play with these, right? If you want to make it easier or harder, you can change the range, or you can change how the marker moves, or the reward levels, whatever. Again, super simple example here. What do you do when you reset? We randomize where the marker and the target are. Just up and down. Collecting a state, right? This is what information do I have about the environment? It's just the distance between the target and the marker. That's all the information this entire thing needs. And then what do we do with when we take a step as an agent? First, we're checking to make sure that the configuration is right and we're in continuous space. But really, we take the action from the brain and we clamp it at -1 to 1, so that is our minimum and maximum acceptable value. We multiply that by the marker speed, and then we move the marker. And if the marker is within range, then we provide a reward with the amount that we said. That's it. That's all there is to this problem, right? And again, part of the idea here is I want have a super simple example. Anybody can come in, hello world, okay, here are the things that I absolutely need to do to get started. So it's a bunch of public parameters, it's 3 methods, it's fairly attainable for somebody who's really just new to this, but at the same time it's also doing good things like making this accessible out here so that people can fiddle with these values and try different behaviors, especially if they use these same kind of patterns and build out to whatever example that it is that they want. It's all right here. So in the environment, we of course have our camera, which is required. That's game camera, directional light, so we can actually see what's going on. The simplest game, which again includes just a marker and a target, right? That's all it is. And the game itself has the agent. So here's all those variables that we're seeing. The marker, nothing fancy about it. It actually has a box collider, doesn't need it, has a renderer, and has is missing a monoscript because I apparently deleted something, forgot to remove that. Our target, again, has a collider, doesn't need it because we're just doing a raw distance, and then has a renderer, and then has that red color. That is all there is to the scenario. Again, I'm not prefabbing this out and getting people into prefabs and whatnot. And I know a large number of you already understand prefabs. But the point here is, again, really focused on just super simple problem so that you can understand it. And then also, even if you're more experienced, it's a super simple problem that you can keep track of all the things so that if you're having an issue with your pipeline and you're saying this isn't behaving the way I think it should be, you have a mechanism to debug. Our generic academy, again, it just is a blank academy. The only thing that I've done is I put a max steps of 250, so this is a time-limited problem as opposed to an event-limited problem. And then here is our generic brain, and I am in the continuous space. The state size is 1, right? We're only getting one variable out. What is the distance between my marker and the target? That's it. The action space is 1, which is how much movement on the y-axis, up or down, right? So in theory, you can input negative infinity to infinity, the float min value and float max value, technically, but then we bound it to -1 to 1. Action space is continuous, state space is continuous, and right now, as a default, I have the brain type set to player. So we can go ahead and play this, and a game window will open up, and I can press the up and down keys, and sure enough, I am able to move my marker and place it on my target. And that is all there is to this game. All right, super simple. It is not terribly exciting to play. However, it is the kind of thing that a machine can learn to play very, very quickly. So now what I'm going to do is, so we don't have any decision in here, right? We're not doing the heuristic type brain. We're just showing, yes, I can play this as a player. I have to be able to do that in order to test it to make sure that it's ready for a machine to play it. And now we're going to switch over to the external brain. So I'm going to go to my build settings and the simplest scenario main, and I'm going to go ahead and build it. And I have my Python here, and simplest scenario is the name of it. I'm going to overwrite what already existed. It's probably the exact same version, but just to show everybody, this is exactly what it should be. All right, so we have that output. I'm going to bring up our Jupyter Notebook. So we're going to go to the basics, and I'm going to load the dependencies, and I'm going to pull up my environment. Now, my environment name is not floaters. That was the previous one that I was testing. So I believe the name on this one was like simplest scenario, or was it the simplest scenario? It's simplest scenario. No, the. Okay, so we're going to set our simplest scenario. We are going to start up the environment. We're just going to start a tiny window, and that has started successfully. That's great. We're going to examine the observation space. Great. And so these are already very close. And then it's going to go through, take random actions in the environment, and then we're going to close it. Okay. So that's all there is for this. Now we're going to go over to the PPO notebook. And again, we had that hyperparameters file, so we're going to go ahead and open that. We're going to use that. I'll show this in Explorer real quick. Here we are. Wrong one. And simplest scenario, and where are the hyperparameters.txt? That'll just open up in Notepad. So we're going to take this and copy it. And we're going to come back into here and load our dependencies, and then we're going to get to the hyperparameters section, and I'm going to just paste this in. This is going to be simplest scenario pass 2, 5E4. So that's 50,000 iterations. Now, this is one of the ones where I made a little bit of a trade-off. 50,000 iterations is, if I had 10 of these running all at the same time, we could actually probably do this in 5,000 iterations instead of 50,000 iterations. However, 50,000 goes pretty darn quick. And then you're actually able to see in TensorBoard some of the trends of what a successful machine learning algorithm might look like. So I thought that it was better to keep it, again, super simple so that we don't have to worry about prefabs and instantiation or any of that, and then keep these hyperparameters at a place where we can watch it train up and we can see our application become a thing. All right, I'm going to load the environment. And there we are. It seems like it has loaded just fine. And then we are going to train. Now, as this trains, you're going to see some progress happening in TensorBoard, right? it only had, I think it was 250 steps, right? So each iteration goes pretty quick. 250 seconds, or 250 steps. I think that's 2.5 seconds. But then it sped up. So you'll see here, after 5,000 iterations, it is getting a reward of 5. Standard deviation is at about 6. And then you can see on TensorBoard, we're going to go ahead and refresh this. So we'll see the simplest scenario past 2 gets the cyan color, and we can see how it compares with the other things going on, that it is doing something. Here we go. And as we can see, let's see, we lost our reward a little bit, and then we gained it back, right? And so as this trains through, we're at 20,000 steps, and we have just doubled our reward from our previous batch. So it's clearly learning something. And again, we're halfway trained. I'm doing this in real time. And then here we go again. We've gone up another 50%. So it's clearly learning, clearly getting better. So we're looking for a high reward with low standard deviation, if at all possible. Looks like we are not accelerating quite as fast now. We may have learned what we need to learn. So again, we can see the cyan line here, and we can see our cumulative reward is going up. And let's see, some of these aren't apples to apples, like this orange one. That's the 3D ball example, right? Our reward for this little game isn't going to get that high. But we can absolutely watch this thing train. All right, 40,000. So we're 80% trained, and we're at a mean reward of 22. And there we go, 45,000. Mean reward of just over 22. And again, our standard deviation, where it had been 6.5, is now right around 2. And then we're done. It's trained, right? And then we're going to go ahead and export that. All right. I think I must have clicked on the wrong thing for getting that error. Okay. So now we go to models, and we'll see simplest scenario past 2, and here's simplest scenario.bytes. So the .bytes file at 4:05, which I didn't realize it was that late in the afternoon already. It's okay. So I'm going to show this here, and then I'm going to take this new bytes file, and I'm just going to do -p2. And I'm going to move it over so we can see that this is past 2. We're going to go back to this generic academy, go back to the brain, switch the brain type over to internal, and we're going to bring simplest scenario past 2. Make sure that you have your graph placeholder, size 1, epsilon, floating point, min and max value of 0, because that's the randomization value. And now we hit play. And we should see, yep, sure enough, the little marker. I'm going to move the camera in a little bit. Right. Yeah, move the camera down and a little closer so we can see. Sure enough, our silly little game is working. And so while on one hand it's a trivial example, it is a trivial example that, again, you can go through and it's like, oh, wait, what was that for? Or what should this format be? Or why does this work or not work? Again, if you can get it going here, then you have all of the core components that you need working together. And if you have a problem here, that means that you have a foundational piece that you need to approach and address before moving on to a more complex problem. Sorry, can you get the code? Well, GitHub. I have absolutely put this on GitHub, so I will put this URL in the description. And then at the same time, I am going to be uploading a Unity package to the asset store. It's not up there yet, and I'm putting it up there for like $2. And it's the exact same code, and the whole reason I'm putting it up there is it's just a way if somebody's like, man, that really helped me. I realized that I had this bug in my thing. here, let me buy you a drink. That's what it's for. So there's nothing fancy about the code in the asset store versus the stuff on GitHub. I'd also never put anything in the asset store before, and I thought that it would be a good experience for me to just try putting something in the asset store. And there are a lot of hoops to jump through. You need images, you need descriptions, you need to go through and upload with their upload tools. It's not impossible. It does take time. So I would definitely say for a lot of this machine learning stuff, they have the machine learning section in the asset store. It is kind of a pain to go through all of that just to get your code on there. So GitHub was far easier, right? I just went, set up a new repo, cloned it to my local machine, tossed my code in there, pushed, and it was done. So, if you're just looking for code or if you're looking to share, I'm definitely going to recommend GitHub over anything else if you're just sharing for free. If you have a really great asset, or again, if you want to go to the asset store, pick this up and say, hey, thanks Blake for the help, here's a couple bucks, then by all means do that. I've thought about doing a Patreon and a bunch of other things, but the truth is I don't necessarily have time to be reliable enough and need to be held accountable. I just want a way that if I am providing value to folks, that that they can go out and get it. And again, I'm not really worried about making this channel, be like a big financial thing. So it's going to be out there. I have submitted the asset to the asset store. Apparently there's a waiting period. They have to go ahead and approve it. But again, please feel free, download this, and good luck with it. If you have any questions, as always, feel free to ask the questions in this video thread. It's probably the way I get the most rapid feedback is when YouTube sends me an announcement and says, hey, there's a new comment. I'll go check it out. And then if you have a question, that's probably the way you'll get the fastest response. So good luck, happy coding, and if you have any questions, let me know. Take care.